we're going to talk about dividing powers. Now, I want you to keep in mind that exponents are just big numbers that have been written as a power so that we can save some room. So they're just like regular numbers that you can add, subtract, multiply, and divide. And so in this video, we're going to talk about how do you divide exponents and what do you do? What are the laws and rules for it? So when you divide powers with the same base, you subtract their exponents to where there's more. So you subtract the smaller exponent from the bigger exponent, top or bottom. And that rule will just kind of simplify things all around for us. For example, you got 2 to the 6th over 2 to the 4th. So in order to do this one, we're going to subtract that 4 from the top and the bottom exponent. And that'll leave us 2 to the 2nd on top and 2 to the 0 on the bottom. And we know that anything to the 0 power, or we'll soon learn that anything to the 0 power just equals 1. So our final answer is just 2 to the 2nd, which equals 4. All right, on this next one, we're going to just minus 3 from the top and the bottom because there's a bigger exponent on the top. So we'll subtract the smaller exponent. We know that this one is just going to be 0 power, so it's just going to equal 1. And then this one will be negative 7 to the 6th power. And we'll just leave it as a power, and you can even drop the 1 for that matter. But we'll leave it as a power until the assignment we're doing tells us that we need to evaluate it. And in that case, we would actually do negative 7 to the 6th power on our calculator and decide what it equals. So on this one, it's just going to be, in fact, I'm going to write it a little more differently. This is just going to be 7 minus 6, which equals h to the 1st power, because we subtracted the smaller exponent from the bottom and from the top, so that we would have one exponent left and it would be a positive one. Okay, let's keep it going. So we notice that in this case, the bigger exponent is on the bottom in every case. So all we have to do is subtract the bottom exponent from the top one. And we end up with x to the 4th power. Subtract the bottom exponent from the top one because it's the smaller of the two exponents. So that leaves us with p to the 3rd power. Subtract the bottom one from the top, and that leaves us with v to the 6th power. Now I'm kind of rushing along here. We realize that we're subtracting it from the bottom as well. But as we saw in the earlier examples, each case these equal something to the 0 power, which equals 1. So basically it just divides out or simplifies out, but we don't need to write it. Okay, let's try this one. In this case, we got some where the exponents is bigger on the bottom. So on this first one, the smaller exponent is on the bottom, so we'll subtract that off, the top and the bottom. In this one, the bigger exponent is on the bottom, so I'm going to subtract the smaller exponent off of the top and the bottom. In this case, the same thing. We've got a 1 on top, so I'm going to subtract 1 from the top, 1 from the bottom. And so when I do this, I end up with p to the 3rd. Oops, almost put b to the 3rd, but p to the 3rd all over p to the 0. And p to the 0 is just 1, so my final answer is p to the 3rd power. Here I would have 3 to the 0 power, which equals 1. And on the bottom I have 8 minus 6, which is 2. So 3 to the 2nd power. On my third example, 1 minus 1 is 0, so I would have 6 to the 0 power, which equals 1. And then 8 minus 1 is 7, so 6 to the 7th power on the bottom. Okay, be sure to keep the base as it is. Do not divide the bases. Don't try to do p divided by p or 6 divided by 6 and get us a 1 or something like that. Follow the rules strictly. Okay, so simplifying expressions with powers, there's a couple of rules that we want to follow that will help us out. So divide or simplify the coefficients first, and then divide the same variables by subtracting their powers. Leave your answer where there's more. Okay, so we're going to start with our fraction, or the coefficients. 18 over 6 simplifies to be 3. And then as far as our exponents, there's more on the bottom than there is on the top, so we're going to subtract the top exponent from the bottom, which would leave us with w to the third power. Okay, how about this next one? Well, we have more y's on the bottom than we do on the top, so we'll subtract that 1 from the bottom and from the top, which just turns that into that y to the 0 power. It becomes just a 1. On the bottom, we have a y to the second power now. And then as far as our x's are concerned, we're going to minus the 5, which is the smaller exponent, on the x's from the top and the bottom. So the bottom one becomes x to the 0, which is just 1. And 6 minus 5 is 1, so I get x to the first power on top. And the one that I had down here, you can just simplify the 1 divided by 1 off, leaving you with a final answer of x over y to the second. All right. Okay, getting a little bit bigger, a little more robust. Let's start with 20 over 12. Now, when we simplify this, let's not make it a mixed number. Just leave it as improper, but simplify it as much as you can. So I believe you can divide the top and the bottom of this by 4 to simplify. Divide by 4. So 20 divided by 4 would be 5. I'm going to write it down here where I have just a little more room. 12 divided by 4 would be 3. So 20 twelfths simplifies to be 5/3. Now on my v's, I'm going to subtract the smaller one from the bigger one. So I'm going to minus 3. Smaller w, I've got a 2, and I'm going to bring that up and subtract it from the top one. So then that means this is eliminated on the top. On the top, I have 3 minus 2 on the w, so that just leaves me a w to the first. And then on my v's, I'm going to do 5 minus 3, which is 2. So v to the second on the bottom. Okay, next one. Look at this. These are written as exponents, but that's not a big deal. We'll just subtract the smaller exponent from the bigger one, so this bottom one from the top. 5 minus 4 is 1. So as I simplify this, this first part becomes 3 to the first power. Then on my 17s, I subtract 15 from the top, because 17 is the bigger of the two exponents. 17 minus 15 would be 2. And then as far as our b's are concerned, we're going to do 21 minus 12. And there's a difference between 12 and 21 of 9, so that's going to be b to the 9th. And then as we did this, we ended up with 1 times 1 on the bottom, because each of these went to 0 exponent, an exponent of 0, which is just 1. So this became 1, and this became 1 when we subtracted the exponent off. So when we can simplify that off, so our final answer is just 3 to the first a to the second, I'll write that more clearly, and b to the ninth. And they're quite easy to do. Okay, so let's try this one. 8 over 9, oh, looks like that's already simplified, right? Oh no, that's 81 over 9, sorry. 81 divided by 9 is just equal to 9 on the top of this one. As far as our x's, there's an x to the 1 on top, x to the 3 on the bottom. So we're going to subtract 1 from the 3, and that'll give us 2 on the bottom. As far as our y's are concerned, there's more on the bottom than there is the top. So we'll do y to the 6 minus 2, which is 4. All right, on our next one, we're going to divide 15 and 35 by 5. So divide each of these by 5. That leaves us with 3/7. And as far as our b's are concerned, 6 minus 2 is 4. So 6, or b to the 4th, because we're minusing the smaller one from the bigger one. And then on our w's, we're doing the same thing. And the bottom w is bigger than the top one as far as our exponents. 6 minus 2 is 4. So we got w to the 4 on the bottom. Look at that. That's kind of interesting, isn't it? So our assignment is number 60, the quotient rule of exponents. Remember to show your work on your paper, and do a good job of showing your work this time so that it'll sink in and you'll understand it and not feel a little bit lost, okay? Be sure to ask questions if you have them. Thank you very much.